Toyota is once again leading the charge in automotive innovation with its latest breakthrough, a hydrogen-powered engine that could surpass electric vehicles. This cutting-edge engine, which operates on water, marks a major advancement in sustainable transportation. Unlike conventional engines that emit harmful pollutants, Toyota's new engine releases only water vapor, offering a truly eco-friendly alternative. With this bold new engine concept, Toyota is set to revolutionize the automotive industry once more. This engine, powered by water and utilizing hydrogen fuel cell technology, represents a departure from both traditional combustion engines and electric vehicles. Toyota's CEO envisions transforming the company from a traditional car manufacturer into a comprehensive mobility leader, driven by a commitment to environmental sustainability and the urgent need to reduce greenhouse gas emissions. Hey, if you're enjoying this so far, don't forget to hit that like button and subscribe for more content like this. Just as it did with hybrid engines, Toyota is positioning itself to once again lead the future of mobility. The company is making significant investments in hydrogen fuel cells, a technology poised to reshape the automotive landscape. Hydrogen fuel cells generate electricity through a chemical reaction between hydrogen and oxygen, with water vapor as the only byproduct. This makes them a clean and sustainable alternative, not only to internal combustion engines, but also to electric vehicles, which often depend on lithium-ion batteries that come with their own environmental concerns. Toyota's commitment to hydrogen technology is evident in its ongoing development of the Mirai, a hydrogen fuel cell vehicle that has already made significant strides in the market. The Mirai exemplifies Toyota's dedication to creating vehicles that are not only efficient, but also environmentally friendly. The company is also exploring the use of hydrogen fuel cells in other forms of transportation, such as buses, trucks, and even trains, demonstrating the versatility and potential of this technology. Another aspect of Toyota's vision is the creation of a diverse range of mobility solutions. This includes the development of autonomous vehicles, shared mobility services, and advanced connected features. By integrating these technologies, Toyota aims to enhance the overall mobility experience, making it more convenient, efficient, and accessible for users. This holistic approach to mobility reflects Toyota's understanding that the future of transportation is not just about the vehicles themselves, but also about how people move and interact with their surroundings. Toyota's focus on innovation extends to its production processes as well. The company is implementing advanced manufacturing techniques to reduce waste and improve efficiency. This includes the use of renewable energy sources in its factories and the development of recyclable materials for its vehicles. By optimizing its production methods, Toyota is reducing its environmental footprint and setting new standards for sustainability in the automotive industry. The transition to a mobility company also involves a significant cultural shift within Toyota. The company fosters innovation and collaboration, encouraging its employees to think creatively and work together to develop new solutions. This cultural change is supported by Toyota's investments in research and development and its partnerships with other companies and institutions. Electrolysis is the foundational process behind Toyota's hydrogen fuel technology. The process involves using electricity to separate water into its components, hydrogen and oxygen. This is done in an electrolyzer, a device specifically designed for this purpose. Water, composed of 2 hydrogen atoms and 1 oxygen atom, H2O, is subjected to an electric current that flows through 2 electrodes placed in the water. The positive electrode, or anode, attracts the oxygen atoms, while the negative electrode, or cathode, attracts the hydrogen atoms. This efficient and clean separation process produces hydrogen gas that can be stored and used as fuel, with oxygen released as a byproduct. Once the hydrogen is produced, several changes are necessary in the engine components to accommodate this new type of fuel. Traditional internal combustion engines are designed to work with liquid fuels like gasoline and diesel, which require specific injectors, fuel tanks, and combustion chambers. Hydrogen, being a gas, requires different handling. The fuel injectors must be modified to handle gaseous hydrogen, and ensure precise delivery into the combustion chamber. These injectors must be designed to manage the high pressure at which hydrogen is stored and delivered. The engine block and cylinder head also need modifications to handle hydrogen. The process of hydrogen is different from traditional fuels, requiring further adaptations in the engine design that of gasoline. This requires specially designed spark plugs and valves to ensure efficient ignition and combustion. When this hydrogen is burned, the primary byproduct is water vapor, which is harmless to the environment. This contrasts sharply with gasoline and diesel, which produce carbon dioxide, CO2, nitrogen oxides, NOx, and other emissions that contribute to air pollution and climate change. By using hydrogen, vehicles can operate with zero emissions, significantly reducing their environmental footprint. While electric vehicles, EVs, are often promoted as an eco-friendly alternative to traditional gasoline cars, there are several aspects where their environmental benefits are not as clear-cut as they seem. One major concern is the production of EV batteries, which requires significant amounts of lithium, cobalt, and other rare earth metals. The mining and processing of these materials can lead to severe environmental degradation, habitat destruction, and pollution. Additionally, the energy used to manufacture EVs is often sourced from fossil fuels, leading to substantial carbon emissions before the vehicle even hits the road. This is compounded by the fact that in many regions, the electricity used to charge EVs is also generated from non-renewable sources, such as coal and natural gas. The disposal of EV batteries poses another environmental challenge. These batteries contain harmful chemicals that can seep into the soil and water if they are not correctly disposed of or recycled. The current recycling infrastructure is insufficient to handle the growing number of used EV batteries, increasing the risk of environmental contamination.